Okay, our last topic in this section are absolute value inequalities. And we're going to have to break this down into two types of absolute value inequalities. Absolute value less than inequalities, and then after this, absolute value greater than inequalities. To try to understand what we are going to do, the absolute value of a number can be thought of as the distance a number is away from zero on the number line. So the inequality absolute value of x less than 3 would mean all numbers whose distance from zero was less than 3 units. And so it would be that set of numbers, that this would be the set of numbers whose absolute value is less than 3. That we can go 3 units away from zero. And so there, and let's hot color that in a little bit more, that those are the numbers whose absolute value is less than 3. That they range between -3 and 3. And so the point here, so the set of numbers shown in the graph may be expressed by the inequality -3 less than x less than 3. And so this implies that the absolute value of x less than 3 and then the inequality -3 less than 3 are equivalent. That those two statements are referring to the same set of numbers. And it's that equivalency that's going to allow us to solve less than inequalities. So steps to solving less than inequalities. Absolute value less than. 1, isolate the absolute value. Make sure the absolute value is less than a positive number. If it isn't, stop. There is no solution because absolute value is always positive and it can't be less than a negative number. 2, rewrite without absolute value using the following format. Negative number less than the argument of the absolute value less than the positive number. Because that's what happened up here. So here we had absolute value of x less than 3. And we said that that was the same thing as -3 less than x less than 3. That we took the negative number, the inside of the less than the inside of the absolute value, the positive number. That's going to be true every time. And so that's what we want to do. Negative number less than the argument of the absolute value less than the positive number, because that's what's happened up here. We had absolute value of x less than 3. It's the equivalent of that. And so what do we have? The negative number less than the inside less than the positive number. So you're going to rewrite it, and then you're going to solve the resulting inequality. Okay, let's practice these guys. This one. And I won't do this to you on a test, but it happens in the homework. Step 1, isolate the absolute value. Got it. Make sure the absolute value is less than a positive number. Negative number. So the thing I wanted there, it's a negative number. Let's see if I can write the word number down. And so the above is asking, where is something that is always positive less than a negative number? It's asking that. Well, positive things are never less than negative numbers. Positives are always greater than negatives, always. This is not possible. And so this has no solution. Or if they use the fancy little empty set symbol, empty set. And so, again, you just have to think before you leap. Some of these may not have answers. Absolute value and negatives just don't really, absolute values compared to negative values don't really make sense. And so you need to think about what's going on, and in this case, it's no solution. Now, when we get to our next type of absolute value inequality, it won't be the same case. We'll reason out to see what we get, see what we should write. But whenever your absolute value is somehow compared to a negative, you need to think about that situation. Okay. Solve each of the following, express the answer in interval notation. So step one, okay, the absolute value is isolated, so we need to rewrite without absolute value. And my form is this, my negative number less than or equal to, in this case, the inside, less than or equal to the positive number. That's always my form. Because since it's less than, and you think about that number line, it's saying that whatever is inside here is trapped between -6 and 6. Because I want to stay within a range of 6 units of 0. So I am trapped between -6 and 6. Notice I do not change that to x plus 1/2. I just take the inside, whatever it is, and I use it. And then I solve these guys. So again, the way we were doing these, cover up the left, decide what to do, and I would clear those fractions. So I'm going to multiply everybody by 2. So I get -12 less than or equal to 2x minus 1 less than or equal to 12. Add the 1, so -11 less than or equal to 2x less than or equal to 13. I'll go up here. -11 less than or equal to 2x less than or equal to 13. I would cover that up and decide to divide everybody by 2. And it's positive 2, so I don't have to change anything. And so I get -11/2 x less than or equal to x less than 13/2. And it says interval notation. So -11/2 to 13/2 with square brackets. Okay, next one. Get the absolute value alone. So in this case, I'm going to divide both sides by -2, and as always, when I have an inequality and I divide both sides by a negative, I reverse it. So that got reversed, divided by a negative. And so I have the absolute value of 4x minus 9 less than 4. And now it's an absolute value less than inequality. And so I rewrite 2. The negative number less than the inside less than the positive number. So in this case, -4 is less than 4x minus 9 is less than 4. Again, because if you think back to the number line picture when we had the 3's, this is telling me that these numbers have to be trapped between -4 and 4. Absolute value can be thought of as the distance away from 0. You can be away from 0 in 2 directions, up to +4, down to -4. So it's saying these numbers here, 4x minus 9, have to be trapped between -4 and 4. Then just solve this. Again, cover up part of it. If I was looking at those guys, I would add 9. So I add 9 to all 3 parts and come up with 5 is less than 4x is less than 13. We'll go up here and finish. And so 5 x less than 4x is less than 13. I would divide everybody by 4. And so I get 5/4 is less than x less than 13/4. And interval-wise, 5/4 to x, 5/4 to 13/4, both with parentheses. And there are my absolute value less than. So the last thing in this section will be absolute value greater than. So we will try to motivate it again. So absolute value greater than. Again, recall absolute value of a number can be thought of as the distance or the number of units away from 0 on the number line. So the inequality absolute value of x greater than 2 would indicate all numbers whose distance from 0 was greater than 2 units. So it would be these two graphs, there and there, that would be the absolute value of x greater than 2. All the numbers whose distance is greater than 2 units away. Well, the set of numbers shown in that picture there is the same as this. X less than 2, x greater than 2. So this side is x less than 2, or negative 2. That side's x greater than 2. And so the point here is that absolute value of x greater than 2 is the same thing as these two separate inequalities, x less than or equal to 2 or x greater than 2. And there's going to be our motivating feature of how to rewrite these guys. That greater than, because I have to get away from 0, I have to be farther away from 0, is going to result in 2 inequalities. And so my steps to solving absolute value greater than or equal to inequalities. 1, isolate the absolute value. Make sure the absolute value is less than a positive number. If it isn't, stop. The answer is all reals or the interval negative infinity to infinity, because a positive number is always greater than a negative number. And we'll discuss that in more detail when we get there. 2, rewrite without absolute value using the following format. Argument, which just means inside, less than a negative number, or argument greater than a positive number, because that's what happened here. Here's the absolute value of x greater than 2. Here's the picture, and it ended up with x, the inside, less than the negative number, and the inside, x, greater than the positive number. Argument inside, less than a negative number, argument greater than the positive number. Solve the resulting inequalities. So there are my steps, and we will do the problems on the next video.